question is, we have to evaluate the value of integration of this function 1 upon x into x to the power of n plus 1. Now to solve this question, first of all we observe the given function which we have to integrate. So in this we have been given x into x to the power of n plus 1. Now, right now, what we can do to integrate? We cannot resolve it into partial fractions right now. We cannot do that. Only thing left out is substitution method. Okay, so I'm going to do, to begin this question, I'm going to substitute x to the power of n is equal to t. On differentiating both sides with respect to x, I'm going to get n times x to the power of n minus 1 dx as equal to dt. Now, further this can be solved as x to the power of n minus 1 dx is equal to 1 upon n times dt. Now, looking at the function which we have to integrate, we cannot do the substitution right now. Why we cannot do the substitution? Because x to the power of n minus 1 is not there in the numerator. So how we could make the substitution work? So that is the main trick about this question. So next what I'm going to do, I'm going to make the substitution work by multiplying and dividing the function by x to the power of n minus 1. Okay. On doing that, I'm going to obtain x to the power of n minus 1 upon x to the power of n into x to the power of n plus 1. Okay, now by doing this, what I'm going to get, x to the power of n minus 1 dx can be written as 1 upon n times dt. Okay, and this x to the power of n can be replaced by t. So the substitution now works. Substitution is now complete. So I can write this as 1 upon n times integration of 1 upon t into t plus 1 dt. Okay. So after substitution, we obtain a fraction which is 1 upon t into t plus 1. This is a quadratic fraction. So to simplify it, we could break it into its partial fraction. Okay, because this is a simple fraction, or you can say a very simple fraction which we have obtained in this question, so this can be resolved into its partial fraction by applying a simple trick, and the trick is that we are going to add and subtract t to the numerator. That is, from 1 we have added to 1 we have added t and subtracted t. Now what we are going to do, we are going to divide the denominator with 1 plus t and this t separately. So I'm going to get 1 upon n times 1 plus t upon t into t plus 1 minus t upon t into 1 plus t. So this and this cancels out. T and t cancels out. I'm going to obtain 1 upon n times integration of 1 upon t minus 1 upon t plus 1 dt. Okay. Now integration of 1 upon t can be written as equal to log t by applying the formula of integration of 1 upon x, which is equal to log x, and similarly this can be written as log of t plus 1. So I'm going to get this as 1 upon n times log of t minus log of t plus 1 plus c. Applying the property of logarithms, that is log of m minus log of n, which is equal to log of m upon n, I can write this as equal to 1 upon n times log of t upon t plus 1 plus c. On replacing t with x to the power of n, we are going to obtain the final answer as 1 upon n times log of x to the power of n upon x to the power of n plus 1 plus c, which is our required answer. So this is how we are going to solve this question. Thank you. Please support us by subscribing to our channel, by liking this video and giving your comment for the video.